Today we are going to discuss important group of statistical methods known as non-parametric test. So we'll be seeing what is non-parametric test, when it should be used, which are the different kind of non-parametric test, and how to perform non-parametric test using SPSS. So let us begin. So what is non-parametric test? You see that when we get the data, we try to clean it, we try to filter our data, we try to see the outliers, whether our data normally distributed or not, and we try to clean our data. But sometimes it happens that however hard you try to clean your data, but still it does not follow the normal distribution. And sometimes we have a small sample, we do not have a large sample. So at that time, we can use non-parametric test to see whether the statistical difference is significant or not. These are the tests which are also known as the free test or non-parametric test or assumption-free test. What is assumption? We assume that our data follows normal distribution. Our data is having a homogeneity of variance. There are different assumptions that we checked when we perform parametric test. And when our data does not follow this kind of assumption, we can use this assumption-free test. Basically, how non-parametric tests work. If we see it, most of the non-parametric tests, they work by giving a rank, by ranking our data. Sometimes it is irrespective of groups. So what is ranking? Ranking start from the ascending to descending order. You sort out your data from ascending to descending irrespective of group, and you try to give them a rank, first, second, third. We'll see it. So what happened while ranking? So suppose we have a 20 data and 19th observation is suppose having a value of 20, and the 20th observation suppose having value of 50. So one observation is having value of 20, another is having observation of 50. So 50 is a outlier. So when you rank data, it will have a rank of 19 and 20. So it has eliminated effect of outlier because it is having only difference of 1, 20, 19 and 20. But at the same time, the people say that the non-parametric test reduce the power of the statistical analysis. Means how? Look at here in the same example. We have observation of 19 and 20th observation, which is having value 20 and 50. So what is the difference? Difference of 30. So it has eliminated that difference by giving a rank, 19 and 20 rank. So only difference of 1. The difference of 30 comma 1. But the other school of thought also said that when our distribution is not normal and it does not following a parameter supposed to follow in parametric test, then it cannot reduce a power. So when our data follows normal distribution, use parametric test, but it does not follow the normal distribution, and use the non-parametric test. So the way we are giving a rank, it will eliminate the outliers, as well as it's also solve our problem of skewness. So these are the test, non-parametric test, Mann-Whitney test, the Wilcoxon sign rank test, fragment test, and the Kruskal-Wallis test. These are the name of non-parametric test. Mann-Whitney is the counterpart of the independent student t-test. Same way Wilcoxon sign rank test is a counterpart of the paired. Friedman is ANOVA, Kruskal-Wallis is repeated measure ANOVA, counterpart of parametric ANOVA. So we discuss when to use, when you have a small sample of the does not follow the assumption. So you have to certainly check whether your data follows normal distribution or not. And if it does not, then you can always perform a non-parametric methods. So let us take example. This is the example where the two group of people are observed for their depression score. Two groups of people were observed on depression score, the extent depression inventory, BDI. So two groups having a one group is having a cannabis and another group is having a alcohol consumption. If we want to see that whether the consumption of cannabis is having a more effect on having depression, or the consumption of alcohol is having more effect on having depression. So basically it is a depression score scale. So we have a two different entity. We have a two different group of people. So we will be using a independent group of test, which is a Mann-Whitney test, counterpart of student t-test, independent student t-test. So it is also known as the Wilcoxon sum rank test. It is similar to Mann-Whitney and it is having a relation with the Mann-Whitney. So what is the theory behind non-parametric test, Wilcoxon sum rank test and Mann-Whitney U test? Don't confuse with the Wilcoxon signed rank test. It is a different than the Wilcoxon sum rank test. Okay, so we have a group 1 and group 2. Suppose we believe that both the group are equal. There is no difference between the two groups. So what will happen? Suppose the group 1 is having a different score and group 2 is having a different score, and we believe that if there is a no difference, then there should be no difference when we are giving them to a rank, and there would be no difference when we are summing their rank group wise. So let us see what will happen. So we have performed a sorting ascending format and we try to give them a rank irrespective of their group. We have a score of 111, 111. So we are giving a rank irrespective of group. So the lowest value will get a rank of first. So we have a lowest value 1 and there are 6 such observations. So there will be a tie. So how to break tie? We have to actually think about their potential rank 1, 2, 3, 4, 5, 6. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6 observation. So 3.5. So that is how you break tie. Similarly, the next 12 observation are having a value of 2. So if we will break tie, there will be a score of 12.5. Then we have to sum it group wise. So there is a sum of group rank and it will be 85.5 and 85.5. So when we believe that there is no difference between two groups, their value should be equal, near to equal. Means there should be no statistical difference between their sum of scores. This is just an example. Let us come back to our original example of cannabis and alcohol. So we have observed them for day 1 and day 5 or day 10, whatever. This is just an example. So these are their score sorted out in a ascending format. You can say day 1 data. So we have a score of 13, 13, 15, 15. So you can see we have a various score which are having the same value, tie. So we try to break the tie by seeing their original ranking 1, 2. So 2 plus 1 divided by 2, 1.5, then 4 plus 5 plus 6, 15 divided by 3, 5. So we have a actual rank 5, 5. Okay, then again, so when we are giving a rank, we does not see which group they belong. So we are giving rank irrespective of their group status. But when we are summing it, we have to again check their group. So this is a group wise sum. This is again group wise sum of their score. Oh, sorry, rank. Okay, now how to check their statistic. So this is the test statistic known as WS, so Wilcoxon sum rank test. It is different from Mann-Whitney, denoted by U statistic. So what is this? So when the groups have an unequal number of participants in them, The test that statistic WS for the Wilcoxon rank sum test is simply the sum of rank in the group that contains the fewer people. Remember, but when the group size are equal, we are using the value of smaller sum rank. Okay, then finally we will be we are calculating a z-score. You know z-score. Z-score is the observed difference divided by standard error. Now how come the z-scores come here? So z-score is basically a difference of the observation, two observations. So what is here? The observation are the sum rank. Okay, so what is WS? WS is the smaller sum of rank. Okay, when the group size is equal. When the group size is unequal, it would be a sum of rank having a smaller group. So that is the sum of rank, WS. Now what is mean WS and what is standard error of that sum of rank? Okay, WS is given by the formula N1, then N1 plus N2 into bracket plus 1 divided by 2. Similarly, the standard error will be calculated by under root n1 n2 into bracket n1 plus n2 plus 1 divided by 12. If this value, z-score value, WS minus mean WS divided by standard error of WS is more than 1.96, then you can say that there is a significant difference between two groups. That's all. Then Mann-Whitney U statistic. It is denoted by the uh, U, and it is given as a formula n1 into n2 plus n1 bracket n1 plus 1 divided by 2 minus a sum of rank from group 1, and is similar to Wilcoxon sum rank test. Okay, how to do it using SPSS? So first you have to check the normality, homogeneity of variance. This is the usual procedure whenever you are performing a statistical analysis using SPSS. This is the general. You want to check the assumption, whether your data following a assumption or not. So how to check this? Okay, let us open our data. So we have a data on cannabis and alcohol consumption and the occurrence of depression. These are our data. And this is depression on day 1, depression on day 5 by using cannabis. So this is the format of structure of data useful to enter the data, how to enter data in Excel or in SPSS. So we have a group of drug, the group of drug, cannabis and alcohol given by value of 1 and 2. Then we have depression score, continuous data. So this is the nominal data, this is the continuous data. And we have used the coding. 1 means cannabis and 2 means alcohol. And we try to compare these two groups for the score. So how to do that? So from the menu analyze, go to non-parametric, where you have a different kind of non-parametric statistical methods available. Related sample means paired observation. Independent sample means unpaired observation. Okay, so we would be using these two options, paired and unpaired. So for this example, we would be going to independent sample. Okay, from the this analysis window and non-parametric test menu, select customize analysis. Don't select automatically compare distribution. Select customize analysis. Okay, then again go to field. Again select use custom field assignment. Now we have a type of drug which will go to group. We have a score which will go to test field. Okay, now go to setting menu. Again use customize statistical method. we have here our two sample, man Whitney. Okay, it will have only a man Whitney name. There would be no Wilcoxon, some rank statistic. Have a Wilcoxon sum rank test menu because it is same as man Whitney use statistic. Okay, so we will click run. Okay, so this is our observation. So the distribution of because we have a two kind of data, the distribution of back depression inventory for Sunday and back depression VDI on Wednesday. So is the same across the category type of drug. Independent sample use statistic. So first is the retain the hypothesis, null hypothesis means there is no difference, and in second group on the fifth day group is having a reject the null hypothesis means it is having a significant difference. So when you double click on if you want to see detail, you have to double click on this window. So it will open another window where you have a detailed analysis and you can see a different group. So this is for a Sunday group. Retain null hypothesis, no difference. Mean rank 11.95, mean rank 9.5. Alcohol and cannabis. See, mean rank is almost same. And when we look at, you can change the group from here, field filter. So for the Wednesday group or for the fifth day group, there would be a reject the null hypothesis and we will have a mean rank of 11.95 and 9.5, and these are the test statistic, and does not have a statistical significance. Okay, so we will changing it to a okay, so this is for the another group, Wednesday group or the group having a fifth day observation. So this is the fifth day observation. Okay, so on fifth day, when we are observing on the next day, we does not have any statistical significance. But when we are observing the same group on fifth day, we have a statistical significant difference. See, mean rank 5.9 and mean rank 15.10. Yeah. The sum of rank is different and it is also having a statistical significance here. From here you can say, and you can change this value from here. And we have one next day observation, we have one fifth day observation or Sunday and Wednesday. From here also you can change Sunday and Wednesday. So this is how you perform Man Whitney U test using SPSS. Okay, how to write result. So what to write in result, how to write it. So depression level in cannabis user median 17.5 did not differ significantly from alcohol user median 16 the day after the drug were taken. Use statistic, you have to mention the use statistic and z-score, p-value, then r is basically a effect size. If you want to learn more, read from the book what is effect size, how to calculate effect size for Man Whitney U statistic. However, by the 10th day, cannabis user median 33.5 were significantly more depressed than alcohol user median 7.5. U statistic for z-score 3.48, p-value and effect size. So effect size is more for the fifth day or Wednesday observation for cannabis. Cannabis having a more depressive effect. To summarize, we can compare two groups using a Mann-Whitney U test when the condition were different participant taken in each condition and the resulting data have unusual cases or violate the any assumption, because these are the assumption free statistical methods. The value of the mean rank tell you how the group the highest score will have the highest mean rank. Report the U statistic, the corresponding Z score and its significance value, and also you can report the effect size if you are well converse with the calculating effect size. You can always mention that because it is also important. Also report the median and their corresponding ranges, or you can draw a box plot. So wherever you are mentioning a median, you should always mention the interquartile range. Okay, so this is all for non-parametric statistical test, specifically Mann-Whitney. So we will see you in the next video really very soon. Thank you.